Today, we're digging into a quiet but powerful revolution that's happening right under our feet. We're talking about rebuilding the living foundation of our entire food system. So, let's get into it. And this is really the central question, isn't it? We spend so much time looking for high-tech, complex answers. But what if one of the most powerful solutions has been here the whole time? Ancient, organic, and literally right under our feet? Okay, so first things first, we have to understand the problem we're trying to solve. You see, our soil isn't just dirt. It's a living, breathing system. And right now, that system is in crisis. This right here is a huge shift in thinking. Soil health isn't some destination you arrive at. It's a dynamic, ongoing balance. And it's all about realizing that things we call waste, like leftover crop bits or manure, can be turned into incredible wealth for the soil. It's about closing that loop and feeding the very earth that feeds us. So how do we actually start this transformation? Well, the first tool is something you've probably heard of, but its biological power is, I think, often underestimated. Let's talk about compost. This is the science behind the magic. See, composting isn't just stuff rotting. It's a controlled process called aerobic decomposition. The heroes of this story are the microbes, the bacteria and fungi, and they need oxygen to do their job. They literally breathe just like we do. And as they do, they break down all that complex organic stuff into humus. That's the rich, dark, stable heart of incredibly healthy soil. And this breaks that transformation down. You start with your organic waste, you make sure those microbes get plenty of oxygen, and you get two critical things out of it: amazing healthy compost and heat. Now, that heat isn't just some random byproduct. It's nature's own sanitation system. It kills off harmful pathogens and nasty weed seeds, making the whole thing safe and super effective. But, and this is a big but, not all compost is created equal. For it to really work, it has to be mature. That means getting the recipe just right. A good balance of carbon-rich browns and nitrogen-rich greens. It needs to hit a stable temperature and have that rich, earthy smell. If it stinks, that's a red flag it's gone anaerobic, meaning no air. And finally, that curing phase is absolutely vital. It lets the compost stabilize and develop the good stuff, like humic acids, which are the real backbone of long-term soil fertility. All right, let's move on to our next amendment. This one builds perfectly on what we just discussed. If compost is the living engine of the soil, then biochar is the permanent carbon-rich chassis that the whole thing runs on. And just look at this number. This is the big headline for biochar. For every single ton you add to the soil, you are locking away up to 3 tons of carbon dioxide. That makes it an unbelievably powerful tool for pulling carbon right out of the atmosphere. So how is this stuff made? It's a process called pyrolysis, and the key phrase to remember here is low oxygen. You're not burning the biomass, you're basically baking it at a high temperature. This process cooks off all the unstable gases and leaves behind this incredibly stable, carbon-based structure that is just full of tiny little pores. This is my absolute favorite way to describe biochar. It's a microbial hotel. That huge network of microscopic pores provides the perfect home, the perfect real estate for all those beneficial microbes we were just talking about from the compost. It gives them a safe place to live, to thrive, and to get their important work done in the soil. The critical word here is synergy. When you combine biochar and compost, amazing things happen. Biochar acts like a sponge, holding on to water and nutrients, and get this, it can last in the soil for millennia. But here's the catch. When you first make it, it's an empty sponge. That's why it's so important to activate it, usually by mixing it with compost first. This charges it up with nutrients and microbes, so it's giving to the soil from day one instead of taking from it. Okay, we've covered the living biology and the carbon structure. Now we need to talk about the non-living, but every bit as essential, mineral foundation of our soil. And to get why this is so critical, just look at the scale of this one problem alone: soil acidity. In South Asia, a staggering 90 million hectares of land are affected. That is a massive, massive area where plants just can't grow properly or get the nutrients they need. And the solution actually comes from the rocks themselves. Amendments like rock dust, lime, and gypsum slowly release their nutrients through a natural process called weathering. It's a slow-motion chemical reaction with weak acids in the soil. So by adding them, we're basically restocking the soil's mineral bank account for the long haul. Now, this is really important. You have to use the right tool for the job. Think of it this way. Lime is what you use to fix acidity. Its main job is to raise the soil's pH. Gypsum, on the other hand, is a structure corrector. You use it in high sodium or sodic soils to improve drainage and aeration, and it does that without really changing the pH. Two totally different problems, two very distinct mineral solutions. And this is the bottom line. This is why it all matters so much. These minerals provide the essential trace elements, the zinc, the iron, the manganese, that plants need for strong, healthy cells. And that creates a direct chain. Mineral-rich soil leads to nutrient-dense plants, which of course leads to nutrient-dense food for all of us. This is how we can help fight hidden hunger, that form of malnutrition caused by a lack of essential micronutrients. Okay. We have our compost, we have our biochar, and we have our minerals. Now, let's bring it all together and look at the holistic recipe for creating truly resilient soil. A key ingredient in this recipe is smart manure management. That means treating it like a valuable resource, not just waste. First, it has to be composted at high temperatures to make it safe, to kill off any nasty pathogens. Then, instead of just guessing, we can use nutrient mapping to know exactly what's in it. That lets us apply it precisely, giving crops what they need without polluting the environment. And this is the ultimate goal. It's a fundamental shift away from that old, linear, take, make, waste model of doing things. When you bring together compost, biochar, minerals, and smart manure management, you create what's called a circular nutrient economy. You're not just mining resources from the soil anymore. You are actively building a self-sustaining system that gets stronger and more productive year after year. So, we end up right back where we began, with a question. We've just walked through a clear, nature-based path to rebuilding the health of our planet, literally from the ground up. So the final thought I want to leave you with is this. If we can successfully reclaim our soil, what else can we reclaim? Our health, our ecosystems, and maybe even our future.